Hi, this is Ben Hobson, Chief Content Officer at Dezeen, and I'm broadcasting live from the Dezeen studio in London. Today we're teaming up with design software company Dassault Systèmes to explore how new technologies such as digital twins, methodologies such as DFMA or design for manufacturing and assembly, and new materials like mass timber are kind of converging to create more sustainable buildings and cities. Quite a lot of jargon to unpack there, which I hope our expert panel will be able to help me do. I'm very pleased to say that I'm joined by Jerry Jackson, who is Director of Architecture, Engineering and Construction at Dassault Systèmes. Hi, Jerry.
Hello, Ben. How are you?
Good, thank you. We've also got Nuri Miller, who's a cloud solution consultant, also at Dassault Systèmes. How are you doing, Nuri?
Hi, Ben. It's great to be here.
Yeah, great to have you here. And finally, we have Kirsten Haggart, Senior Associate at Waugh Thistleton Architects, a London firm of architecture, that's done a lot of pioneering work around construction with timber. Hi, Kirsten.
Hi there.
Good to have you on the call. Jerry, I'll go back to you to start. Could you just tell me a little bit about what you do at Dassault Systèmes and where are you in the world, actually?
Yeah, Ben, sure. I'm here in Northern California, so I think 8 hours behind the UK. And for Dassault Systèmes, I work within the AEC organization at Dassault Systèmes. And I've been doing that for just right at 10 years now. And I've been in the technology side of AEC for 20 years, for the better of 20 years now.
Great. And Nuri, what about yourself?
Yeah, I'm a worldwide online industry business consultant at Dassault Systèmes. So I focus on the cloud and collaboration. I'm a licensed architect, so I have a deep background in AEC. And I've had a number of years of experience in design technology leadership positions at places like Walt Disney Imagineering and Gehry Technologies, Frank Gehry's technology firm, where I've really been focused on taking expertise and knowledge and translating it into automation so that we can more easily translate that knowledge into really high fidelity automation in the AEC industry.
Great, thank you very much. And Kirsten, yourself.
Hi, I'm Kirsten Haggart from Waugh Thistleton, as you mentioned. We specialise in sustainable timber construction. I was the project architect on one of the first tallest timber buildings in the UK, Murray Grove, and I now head up most of the research projects that we do and a number of the international projects across Europe, from Sweden, Italy, and a couple in the States.
Great, thank you very much. And I think I'm in the Dezeen office, and we're actually next door to we're in 8 Osmond Road, and I think you did the building next door, which is, I don't think it's all CLT, but I think it's a hybrid kind of steel CLT construction. So we're neighbours of the sort. Great. Nuri and Jerry, if you guys could kick us off with your presentation. I think you're going to talk a little bit about Dassault Systèmes, your kind of software solutions around DFMA and kind of virtual simulation technologies. Kick us off.
Great.
Yeah.
Can you see my screen?
Yep, looking good.
All right.
Yeah, so we're really looking forward and happy to be here. We've been looking forward to this opportunity and happy to be here to talk about virtual mass timber and how it extends and improves real mass timber. It tends to be the nature of virtuality a bit. And so we're really thrilled to be here. Dassault, just to introduce Dassault Systèmes, some might be familiar, but Dassault Systèmes is a software platform company. We have a portfolio of apps which encompass the entire life cycle from design to manufacture and beyond. So that, in a nutshell, is Dassault Systèmes. And to give you a little bit of context, to give you a little bit of our history, we have kind of a parallel tracks here. What you see is Dassault's core history, and then right below it, you can kind of see how it tracks with AEC over the years. And so Dassault, if we look at the top portion of this, Dassault was born from aviation. In the mid to late 70s, it became necessary for the aerospace industry to better control costs. From this need, Dassault Systems created a 40-year legacy of innovation, ranging from really the first full digital mock-up, 3D digital mock-up of a significant product, that product being the Boeing 77. Then we moved on to product lifecycle management. How, if you're creating these digital mock-ups, that's fantastic, and that creates a lot of opportunity. But then the question was asked, how do you manage that digital mock-up and all of the components that make up that digital mock-up? How do you begin to virtually manage them over a life cycle? And then we moved on to an investment to become more of a platform company. And that happened when we launched the 3D Experience platform. To our most recent work, which is moving all of the innovation we've done over 40 years and bringing that to the human experience by beginning the effort to virtualize, to create a virtual twin experience of people, of humans. As we kind of transition to the bottom half of this slide, as our first decade closed, many on this viewing here today would remember, Frank Gehry somewhere about 1991 getting both the Disney Concert Hall and the Bilbao projects very close together. And with those projects, he began to find the same need as aerospace. He identified the same need that aerospace identified 10 years earlier when Dassault was formed. What started with Bilbao has now reached mass timber, all the way to what you see on the far right-hand corner. In the mass timber side, you can see, if you can read it across the screen, it's hard to compete with the tallest. It depends on the region, of course, and the moment. Mass timber is a fast-moving segment of the industry. But back in 2014, what's known as Brock Commons, or sometimes Tallwood House from UBC Properties in Vancouver, they began to create a virtual twin of the Brock Commons product, if you will. And that kind of began our entrance into the whole mass timber side of segment of the industry. It continues to extend all the way down to some of the smallest organizations. And what you see in the lower right-hand corner is a husband and wife team who use the 3D Experience platform to design, manufacture, and assemble eyebrow dormer windows from their garage. And so we've taken this parallel journey that you see has really been a phenomenal one. And there were pauses in between, I would say, but the two processes, and that's what's interesting about mass timber, is that mass timber presents such an opportunity for that design for manufacturing and assembly process that the aerospace industry started to identify, 45, 48 years ago in the mid to late 1970s. And what we're seeing is that mass timber, no pun intended, is bringing that to the masses, which is really well represented, not only by firms such as Waugh Thistleton, but also of individuals, smaller groups, like the husband and wife team.
So, if we consider the fact that mass timber is more of a manufactured product, the example in the case again of what's sometimes referred to as Brock Commons or Tallwood House, this virtual twin, this high fidelity system, 3D representation and system, was really a way to test and virtually build everything for the project. And it brought all the trades together so that down to, you know, the manufacturer, the CNC code itself was at the end the ability to really hone in on what where everything would fit in the building and how it would all come together. This really, you know, for us, really emphasizes our belief that the virtual worlds extend and improve the real world. They extend them because we can test ideas in the virtual world in ways that we cannot in the physical world. So we can test many scenarios, we can go through many iterations, and we can improve the real world because we can choose the best one. And that was the case for this project, where they achieved 70% efficiency and reduced cost than a traditional concrete building. The idea of the virtual twin experience, where we can test and really look at different scenarios, is really covered. If you look at this loop between the virtual and the real, we're testing ideas, we're looking at different scenarios, but we're also taking the expertise and knowledge to improve the virtual. So we're taking, and this is really a key part of this process, is that we're digitizing knowledge. We're taking that tacit knowledge from experts, and we're translating it into automation that can be that can really achieve a lot of different scenarios and at a high speed and fidelity. And this whole ability to test in a virtual world is really benefited from this approach, which is many times referred to as DFMA, or design for manufacture and assembly. And what does that mean in terms of construction? Well, we're able to automate and really focus the design process more on how the products and the pieces of the building come together in a very accurate way. So at the end of the day, what's different about a DFMA approach is that your deliverables are no longer just about drawings, but they're about a bill of materials. And a bill of materials is just, you know, a complete collection of all the bits and pieces that come together, the connections and the members of the entire built environment. And we can see that this can happen at any scale. So as Jerry was mentioning before, you know, we have customers who range in scale using our technology in the cloud, and it allows them to again take some of that knowledge. In the case of this customer, Ibro Window Dormer Supply, that's based in New York, they wanted to use the platform, the 3D Experience platform, to validate that they could produce their product off-site and have confidence from the architects that they could perform this. And so you know, there might be they're not necessarily Boeing or Toyota, but they can use the same technology in the cloud and collaborate in that way.
Yeah, to build on what Nuri was describing, we thought it might be instructive to use a diagram, an illustration that has been around for, I would say, close to 20 years now, well known as the McLean curve. And in this McLean curve, if we think about DFMA, we think about mass timber in context of this McLean curve, this is a good place to begin because it was distributed so widely. And the thing about one item to know about the McLean curve is it was informed by processes and technology broadly experienced by AEC. But it was not the processes of mass timber, such as DFMA. It was more of the legacy processes that it was informed by. And therefore, it really operates under the premise that the two curves you see on screen, the ability to impact cost curve and the cost of design changes curve, cannot be modified. They cannot be touched, if you will. And because they operate and because this idea was informed by legacy processes and not by more advanced processes that mass timber brings about and virtual twin experiences bring about, such that that it proposed. Nuri, if you could go back to the previous one just for a moment, it did this by proposing that you need to make a change in effort. And in different circles, this change of effort sometimes was known as integrated project delivery or IPD. So you actually, they saw the curves as not movable. And so they went after the effort actually and started to shift the effort early on. And again, these are more legacy processes. Thanks, Nuri, for going back. Ready for the next one. So a virtual twin experience has an alternative belief. It believes that the two curves can be improved to what Nuri was saying, that our belief is that the virtual world improves and extends the real world. Here's a concrete kind of example of that. And that we believe the two curves can be improved and extended such that scope and quality far exceed the time and cost to produce. The result is that virtual twin experience curve, virtual twins improve and extend effort. And that's where you start to see the matchup a bit. And it's a significant difference, but it is so important. It's the advancement in so many other industries, automotive, the Toyota production system, what Boeing accomplishes and what enterprises much smaller than that accomplish. But it is important. And mass timber and DFMA are critical to that. And mixed with virtual twins, it really is a natural matchup that's been waiting. It's been in the waiting for years. And again, it's mass timber that's making that all possible. And the existence of the innovations that the Boeings and the Toyota production systems of the world have refined over 40 years. And so it's just a remarkable time. So that's kind of looks at the curve. Now, I wanted to lastly put this curve in context side by side and put it to an equation. And this equation came about by Stephen Kieran and James Timberlake in their 2003 book called Refabricating Architecture. But this is, the comparison between the McLean curve and the virtual twin experience curve is a perfect explanation of that equation. So the McLean curve, as we said before, accepts that the curve cannot be touched and you have to change effort. And what that results in is an inability to change the equation, you can change the terms of the equation, but it remains inequality. So that if you try to lower cost and time to keep that equality true, then quality and scope also lowers, or vice versa. If you try to increase quality and scope, then cost and time also increase. And that was well captured by Refabricating Architecture and by Stephen Kieran and James Timberlake. And if we look over to the right, the equation, the inequality, if you will, expressed in terms on both sides in Refabricating Architecture, proposed, based on his research in aerospace and automotive, that both Stephen Kieran and James Timberlake proposed that indeed in the built environment, and we know all of us know in this live broadcast, and Kirsten, I'm confident knows. I mean, she experienced it firsthand that mass timber and DFMA processes present an opportunity to deliver quality and scope that is greater than cost and time. And I think that this equation kind of presents that really well. Those two ideas. Thank you.
Great. Cheers, Jerry. Thanks, Nuri. If you could unshare your presentation. Great. I had a couple of questions before we get on to Kirsten. First of all, could you maybe just define for people who are maybe not familiar with or maybe heard it but not sure what a digital twin or a virtual twin is, and in particular, like how does it differ, for example, from like BIM models or things that architects have been using for some time now? You showed the kind of one of the diagrams you showed the kind of loop. Can you maybe explain a little bit about how that loop completes and how the relationship between the virtual model and the real world building or whatever it might be, how they relate?
Yeah, Ben, there's a lot to tackle there, but let me offer up a working definition, if you will, so that for this broadcast that we could at least work from. And so, a definition that we think about at Dassault Systems to keep it as broad, and there's nuance that lies underneath, but let me offer this definition. So virtual twin experience is a process that can retain the built environment's complexity and replicate the information specifying how it was developed. Now, with that definition, there are a number of attributes to that. One is a model of the product. And I think one thing to think about is it's true with mass timber and DFMA. Mass timber and DFMA, by their nature, move the conversation from project to product. So it goes from project execution to product development. And so one of the attributes is this idea of a model of the product. And there's also this idea of an evolving set of data related to the product. And then the automation through digitized knowledge and know-how in the regeneration of the product as well. Kind of that full circle loop that Nuri was talking about. This idea that you can take human tacit knowledge and make it and digitize it and make it digitally explicit. And where does that knowledge find itself? Well, it finds itself in that bill of materials Nuri talked about, in the components. If the component, it belongs to MEP, to plumbing, let's say, mechanical, let's say, or plumbing, then how do you take that knowledge of the trade expert, their tacit knowledge after 20 years of work, and how do you bring it into that component? Is one example of that full circle. And then, of course, that continues improvement. But that's a real practical way in which it's being leveraged today. Not hypothetically in the future necessarily, but it's happening every single day in a number of different mass timber projects around the world. And then the other attribute is a novel digital language that can capture and reuse the full nuance from all specialists, from every single specialist. And, to compare it to, I think you said maybe compare it to BIM. BIM, in generally speaking, is a representation. It's not necessarily, by its use, a virtual or digital twin. It's a representation or a proxy. It's a stand-in for the real thing, rather than every single possible component from every single possible specialist with their combined and collective knowledge brought into it. And so I would say that that's one key attribute. And the other thing is, these key attributes is this idea of a novel new language, and then then all human advancement has really been with language, kind of an improvement in language, but it's also been a new way of communicating. And this new way of communicating, part of that broader definition, is through platforms, such that you begin to trade in information goods, and you begin to trade between the trades and their knowledge that's been captured in such a significant way that the trade through these online networks and platforms begins to feel, well, it begins to feel free because of the number of transactions, and it's perfect and instant. And that's, I guess, some of the ways I would explain that it's different. I hope that helps.
Yeah,
one thing
oh yeah, go ahead, Nuri.
Sorry, I was going to say that one thing I would just briefly emphasize, as Jerry said, the word BIM is kind of a proxy. I think the main test for that is what are your main deliverables? And if you're a professional and your main deliverables are drawings, then it's more of a BIM process. But if your main deliverables are drawings and a bill of materials encompassing the entire system of the building, then you're really talking about a virtual twin.
And like we've published stories on the zine about various kind of ideas of virtual twins, like from a kind of bit like a building or through to like whole city, kind of, more like for infrastructure and planning and things like that. And I guess the key thing, and they're different in different ways, but the key thing, I suppose, is the kind of that they're taking the data from the real world and using that to inform the digital the digital twin. So, and in that way, it becomes more than just a kind of representation. It's a kind of a digital. Well, it's a twin. It's a kind of version of that. I wonder, are you able to give some examples? I mean, maybe with the Block Commons project you mentioned, or other projects of that data that you talked about, that information from all the different kind of industries that might work on a building, and especially if it's kind of productized in this way. How do you get that information? How is that knowledge taken from the kind of silos of the different disciplines, and how is that imported into the virtual?
Yeah, no, I think that's good. I'll let Nuri get into the real technical side of it, but let me just say quickly that in a real practical way, I don't want to overstate. I'm very careful, and Dassault's very careful about operating the way things are happening, the way we see it happening today with virtual twins. And, we see the promise of kind of what you said, where you might have sensors feeding it back. It's not the daily experience that we're seeing in any kind of scaled way. There's many more practical opportunities right in front of us that are not being done. That is being done in aerospace and automotive, and that is this digitizing of knowledge. So you were saying, how has it brought that full circle? Well, we may not be grabbing a sensor necessarily and getting live data where we're calibrating a virtual twin model, but what really happened on Brock Commons is that the team that was responsible, in this case, it was an organization named CAD Makers, the team that was responsible for capturing that knowledge and digitizing it would interview the trades. So what better real way of getting feedback than the tacit knowledge of all the different trades? And then they would take that tacit knowledge of individual trades using our novel digital language, which Nuri, we don't have time here, but Nuri can speak to it a little more in the technical side. It's called enterprise knowledge language. And it's a way of capturing this knowledge at the component level in full nuance of the different trades, so that information could be traded at scale. I mean, we've always communicated. People have always communicated. But it's that the level of detail and nuance and how many people can communicate and how that knowledge can be embedded and reused that really makes the difference in the virtual twins. It's all about scale and reuse. So I hope that helps. Nuri, anything to add?
Yeah, I guess one thing I would add is that it's important to to work in a platform environment and to have a common data model for, on the technical side, that everyone, in the case of Rock Commons, for instance, all the trades, all that knowledge that came from the trades was translated into this high fidelity virtual twin that was in one data environment. So everything was being done, in this case, in Dassault's 3D Experience platform. But what was important is that it was all this common data environment where everything worked together seamlessly. And it wasn't about translating and importing, exporting, and all of the kind of process that happens there. But it's about having this common language, as Jerry was saying before, and a way of very seamlessly sharing and collaborating on the same data. So having, as much as possible, a centralized repository of data that everyone can collaborate on.
And one more question for you guys before we move on to Kirsten. You kind of, at the start, you gave a little history of Dassault Systems and showed how it kind of came from the aviation or like automotive industry. And I suppose a lot of the things that you're talking about are kind of applying those same processes or things that have been developed in those industries to construction. And I suppose it's something that has been tried to be done for many years, like some kind of form of kind of prefabrication or making processes more efficient, all that kind of thing. Why do you think now it's becoming kind of possible in any kind of significant scale?
A few thoughts on that. Boy, that's just an open. That's a great question, by the way. Let me try to go as quick as I can. I mean, there's so many things that are playing with that. So back in the Frank Gehry days, goodness, back when Frank Gehry was doing this first with Bill Bow in late summer of '91, and they were first. I mean, when our technology at the app level, known as CATIA, was brought to Frank Gehry's office, he was operating off of pencil and paper. That was it at that time. And at that time, CATIA, our technology that aerospace was using in automotive and others, it wasn't on the Windows environment. There wasn't even Windows 95, right? It was, I don't know, Windows 3.0 or something. And we didn't even write for Windows at the time. And it was a Unix system. And so can you imagine what Frank was doing at the time? That was crazy. It was wild. Frontier, no doubt the frontier. There's no question about it. And beautiful art and components came from that. We know that, right? And it was kind of the Bill Bow effect, if you will. But what makes it scalable now? What makes it different? Well, there's some IT stuff in there, unrelated to Dassault. Right? Amazon Web Services, other web services, data centers, all these things, the speed of the internet. There was no internet when Frank was doing this in '91 to speak of, really. And so, there's IT infrastructure, speed of information that can transfer, the amounts of data that can be transferred. This idea that we're doing this live broadcast with streaming video is an example of that, right? So all of that kind of infrastructure needed to be in place. And I would say over the last 10 years, it's very robust. And so that's one part of it. And then I don't think there was quite a scalable business model. I think for Frank, there was a business model. You had these unique projects that had requirements that people were just not seeing, had not quite seen before. And so, he had, in those kinds of projects, there was a business model inside of that project that can pay for kind of the R&D, if you will. But now, mass timber brings that at scale. So now you have a very old material, but a very new technology making use of that material. And you take that new material, or the not new material, but new technology for an old material, and you mix it with the DFMA process and the advancements such as virtual twins, and it begins to happen at scale. Again, with the aerospace technology, there was a lull there, but that was just because there was no easy way of simplifying it for everybody at the end of the day. And of course, IT infrastructure helped do that, and innovations at individual software companies help do that. More and more every single quarter, if you will, perhaps twice a year on our side. So much of the most wild of our CATIA technology with this enterprise knowledge language that we speak of, we have it as streaming applications. There's not even code on your machine. It's completely just streamed. So it doesn't care about your operating system, your graphics card. It doesn't care about any of that. It could be your phone. And all of that combined makes a business model of it. And then you have the need for affordable housing. You have a big need out there. The need isn't another Bilbao. The need is affordable housing for society, and close to 8 billion people we're getting on the planet. So you've got a strong need out there by a large group of people. You mix all that together, and with a material people are familiar with, and that can end up taking a large scope of the project, which Kirsten can talk much better than I can about. But the idea that it becomes your walls, it becomes your floors, it becomes your columns is really exciting. That's the quickest way I can answer it.
I think too, also with mass timber, we're seeing a greater number of or larger scale of the building being manufacturable, right? We're being produced in factories, and that's really, I think, key part of why now and why mass timber.
Great. Well, that's a very nice, convenient link to go on to talk about for Kirsten to talk about what she does at Waugh Thistleton. Kirsten, are you able to share your screen now?
Yep.
Yeah, looks good.
You see that?
Yeah.
There we go. So we're Waugh Thistleton Architects. We're based in Shoreditch in London, and we have we're in a sort of shopfront office, open door policy, and we have been working towards a sustainable architecture for the last 15 years. We work a lot with timber, but we also are completely open to ensuring that whatever project we're approaching, we use the correct material for the context and its environment. So you can see the image on the right, which is Bushy Cemetery, which was nominated for the Sterling Prize a few years ago, is made of compacted soil. So it's sort of compacted, the earth from the site was used to create the walls and created an absolutely beautiful space. So our ethos is about thinking from the outset about the integration not only of everything from the structure to the services to the well-being of the individuals that are going to be working in the office or the houses that we design. And in terms of innovation, about 15 years ago, we were getting frustrated by the traditional nature of building, how nothing seemed to have moved on for years and years. And we wanted to try and find a sustainable material that spoke to the housing crisis, as was mentioned earlier, that allowed us to build more quickly in a sustainable way. And that led us towards CLT, cross-laminated timber, which is panelized timber where there are boards which are laid in perpendicular to one another, glued together, and become much stronger than their individual parts. So you can build quite tall and some quite large structures with that. And we started actually with an extension to a club near Waterloo, which was only 2 stories, and the whole thing was built in a couple of days. And we thought, well, we've got to really take advantage of this. So in our processes along the way, we wanted to spread the knowledge of what we learned. So we make sure that we're producing design guides for clients or books that are open to everybody about CLT and timber construction, as well as working with universities and on research projects, which I'll touch on at the end of this presentation. So in 2008, we built Murray Grove, which was a housing development for metropolitan housing. And the first three floors rather, or the ground floor was concrete. The first 3 floors were social housing, the rest was private. And when we designed this, this was the tallest at the time. You're absolutely right. The tallest is never always the tallest. It changes over time. When we designed this, there was a lot of caution because it was the tallest that had been built at the time. So it was a very neat solution in that all the panel sizes were exactly the same and the thicknesses were exactly the same. And we created, as you can see there, a kind of honeycomb structure. But it was very timber intensive. Talking about BIM and CAD, I mean, literally, they made the drawings for the CNC machine in the factory for them to cut out the panels, and I had to manually check those. They were printouts, so that's not that long ago. But what the benefit of this is that it is incredibly fast. So when you're building in an urban environment, as we do in the centre of London, the whole structure went up in 49 weeks, which was, or actually the structure for the CLT went up a floor a week. So we got a lot of progress very quickly, and then we were able to make that watertight quickly, and then the whole project was completed within the 49 weeks. So it's also incredibly quiet. The number of deliveries to site are minimized because you've got a panelized system rather than a system that's made out of multiple parts like you would with a cladding rail system or steel frame or any of those frame type products. And you can see here that the environment within which the builders work is very clean. It smells really nice. And it's very easy to work with. Each panel, all the way up on every floor, is just connected by these, I don't know if you can see that, these L-shaped brackets at the bottom of the wall. And all the fixings for electrics and services are very simple, just drilling into the timber. And the accuracy the tolerances are very small. So again, compared to a cast in situ concrete building, it's the tolerances are much better. So it's very quiet. There's less waste as well, because in the factories, the timber came from Austria, from KLH. The factory actually uses all their offcuts of timber to make into pellets to fire the burner that creates the energy for the factory itself. But even on site, you've got so much less waste because every panel has been designed and fits together perfectly. It's very quiet, and it's as I mentioned, fewer deliveries, but also incredibly lightweight, which then has a knock-on effect on its carbon footprint, in that your foundations don't need to be as big and you're not using as much concrete in the foundations. So the next project was a sort of iteration of that, where we worked on Dalston Lane, which was again a large housing development with a small amount of commercial in it. And on this project, the efficiency of the timber improved because of our experiences and because of I think the advancement as well of the structural engineers' use of calculating the size of the timber. So I think the design really had the structural stability came around this sort of donut idea, where you had a strong exterior wall and core, and then the internal walls didn't need to be quite, we didn't use the same strategy as having all the same thicknesses all the way up. And as you went up the building, even the external walls could get thinner. So ended up with a much more materially efficient building, which, although we're very keen on using wood, we want to make sure that we're using the minimum amount so that lots of other projects can use it as well. But here we had 121 homes, and all the, as we were saying earlier, the improvements over what was the design criteria for acoustics and airtightness were really marked on this project. So because everything's so precision engineered, the connections are really tight, so you therefore get very good airtightness and acoustic performance, which is another advantage. But on this project in particular, it was also an economic advantage for the client, because we managed to get 25% extra homes in the development, because the foundations didn't need to be as deep. And that was because there was a kind of a protection zone for HS2 underneath the building, and we couldn't pile it. So this building is not actually on piles, and the concrete foundation and basement was sufficient because of the lightweight structure enough above to then allow another 25% homes on the top, which was, you know, obviously a great sell for the client, but I think a big advantage for the project generally. So then, as we've become more experienced with CLT, the benefits of DFMA, design for manufacturer, have become more and more apparent, and we've been thinking and trying to expand our knowledge not only of timber but as the broader piece of DFMA, and have worked with L&G and Swan on their modular housing. Swan decided to develop a CLT modular product, and you can see here one of the many advantages is that you're dealing with so many fewer parts to the module when you're designing in CLT. We worked with them on the design guide, and it was really interesting to look at the McLean curve that you were showing earlier, because what we started to think about was, in terms of manufacture, and I'd be really interested to have a longer discussion about it, but when you're designing a module, you actually need to design everything much earlier, so that once the production line gets going, then there are very few changes, because stops and starts on the production line can have quite big economic problems for the factory. But yeah, it's a completely different way of designing, and the way that we are all kind of trained as architects to go through all the REBA stages needs to be reviewed. And actually, one of the first things you think about is how the modules get to site, and if there's any low bridges. So that's the project that's going up at the moment in East London. And finally, I just wanted to talk about the Building Wood research project that we're doing. The Danish Technical Institute are heading that up. And the purpose of the project is to make mass timber and timber construction generally more accessible across the European market by setting an example of a particular system, but also testing that system, having it readily available in BIM with all the components associated with it. And we haven't got as far as doing a digital twin for it, but I think we should be looking to that. And also, in terms of sustainability, this idea of life cycle analysis and making sure that the embodied carbon of every component within the building is captured in the BIM model. And it's a really interesting project, because we're going from looking at the glue that sticks the CLT together, or using recycled components of timber within the panel, to then talking about policy on timber and how we can encourage more of it to be used across Europe. And also thinking about this system, we needed it to be demountable, recyclable for disassembly as well. And it can be used for residential, commercial, and retrofit. It's a kit of parts is how it's conceived. So thinking about it as a series of components is a really interesting idea, particularly in the digital world as well. And it had to actually be, we had to design it so that it could evolve to any building regulation in Europe. So the way that the facade panel is designed is in a 3-layer system, so that you can add insulation, you can add fire protection on the inside, and it's completely adaptable. So we have a phrase that we're designing a process, not a product. And I think that's really key when we're talking about DFMA, that it's not something that you think it's just an off-the-shelf thing and you only have one option. There has to be inbuilt adaptability and flexibility in the system. So this gives you a sort of idea of what the kit of parts what the kit of parts is. We've got CLT floor plates, and we've got rib deck. We've got this is actually a post and beam structure, again playing into this idea of material efficiency and making sure we're not using material where we don't need to. So we've got the floor plates are all CLT, but the structure itself is post and beam. And also this notion as well that we must always be thinking about how we can record and ensure that the embodied carbon of any given building is recorded and minimized. And hopefully that's going to mean that we have a myriad of possibilities in building in timber across Europe. Thank you. And the world.
Great. Thank you very much, Kirsten. You mentioned a couple of times there the idea of the embodied carbon. I wonder if you could maybe just talk a little bit before we talk about how the material is used and the efficiencies there. The material itself, I guess it's kind of held up as a great hope, I suppose, for kind of a more sustainable way of building, because unlike other structural materials like steel or concrete, you know, the trees grow, they suck the carbon out of the atmosphere, it's stored in the wood, as opposed to processes which expel vast amounts of carbon. Can you talk a little bit about that? I mean, it's in some ways it sounds a little bit too good to be true. Is it the great hope that some people say that it is?
Well, we think it is, yeah. And also we have 7 early adopter cities for the Build in Wood project, and the interest from policymakers is huge in timber at the moment. The reason, and I don't know whether people know the difference, but there's energy in use, which is all the things that we do about making sure you've got low energy light bulbs, that the fabric of the building is thermally insulated so that you're minimizing the amount of energy you're using. And that now is being offset more by renewables through the grid. So we're actually doing quite well with energy in use, but what we're not considering it's becoming more and more important, and we've really seen a difference in the last year of GLA policy. There's been a document by Letty, which is fantastic, about embodied carbon, and people are thinking about the actual carbon it takes to make the products that go into the building, as well as transporting it, and then how easy it is to reuse those materials later in life. So that whole piece around the embodied carbon is captured in what's called a life cycle analysis. And a life cycle analysis, actually, when you compare steel, concrete and timber, in the way that that's calculated, the life cycle analysis doesn't actually take into account the fact a material is renewable or not. It's only whether it's recyclable. So when you're thinking about timber, it is recyclable, but it's also got the added advantage of being renewable as well, which means it has sequestered carbon. And that is the big thing that makes all the difference when you're building in timber. Your embodied energy levels go right down. I hope that made sense, but I think there is we're looking at Trondheim in Scandinavia. They've actually got timber first policies for some of their areas in their cities. So I think it's becoming more popular.
And you mentioned the idea of not just what's used to build materials, but how or if they could be reused. And I suppose if we're thinking of like sequestering carbon, that needs to be an important part of the equation, because you might take away some carbon temporarily. If at the end of that building's lifespan it gets knocked down and the timber is burnt or it decomposes, all that carbon will go back into the atmosphere. And obviously, like the circular economy, circularity is another of these kind of things that everyone's talking about at the moment. I wonder if you think that some of the material itself, and also this kind of designing for manufacturing and assembly, this kind of taking a more kind of production line approach to architecture, does that facilitate the possibility that buildings could be kind of demountable in future and reused, and these parts could kind of circle in different buildings, so they don't just have the lifespan of the building, but many buildings, and reduce things that way?
I think that's definitely part of our research in the Building Wood project. I think it's also worth noting that often when a tree is cut down, they plant 2 or 3 more to replace it in a sustainable forest, which all the forests that that CLT and other construction timbers come from, all the ones we certainly advocate do. And I think that the idea of, and I think it's something we've got to use whatever material you're building with, but this idea of demountability, because it's being able to take buildings apart in a simple way and using them essentially as material stores through their lifetime. So then you might not be able to use the whole building, but you'll be able to use components of it. And I think there's a whole piece around how recycling works and how we can certify building elements and components once they've been used in a building, and we don't just continue with the throwaway economy, because that's just not sustainable, as we all know.
Jerry and Nuri, when the project that you've worked on, is that kind of idea of disassembly part of your thinking when you're creating these virtual models of and designing these kind of construction processes using CLT or other mass timber?
Yeah, the one that we can kind of speak to, there's many projects that are happening, but the one we can kind of publicly speak about, which is the Tallwood House, Brock Commons, is I don't know how much of that was part of the conversation, in that they were breaking so many firsts, as Kirsten has done with many of her projects. So they could only take so much on at the time. And so I don't really think it was part of that. But I do know that it's just a nonstop innovation factory from project to project. And I know UBC Properties is looking at other opportunities. But I do know one small startup in Luxembourg. And that startup is called Laco Labs. If you haven't taken a look at Laco Labs, and Laco Labs is delving into what Kirsten has so well articulated, and this idea of how is it disassembled and then reassembled. And Kirsten, you said something really interesting. And did you say like it's a product warehouse? A building becomes a product warehouse or something like that?
Yeah, a material store. Yeah,
a material store. I love that. I wrote. Yeah, I gotta make note of that. Exactly. And so I do know that there is a small startup that is doing that, and they're taking a little bit of a twist on mass timber, but that's one of their key goals. Which again, it's neat to see these startups, right? They're getting their motivation and their inspiration from firms like Waugh Thistleton and people that come after and at the same time, and you just see a lot of innovation. Which, you know what, that happens when you take a very recognized and comfortable material that's, my goodness, who knows how long we've been building with wood. But then you apply a brand new technology to it, mixed with all of these needs, top of which is affordable housing. And I just see it throughout the world. It's amazing to see the innovation that's happening around mass timber.
And how you mentioned like affordable housing, and obviously that there's a kind of dilemma there, I suppose, in that we're trying to reduce our impact on the environment, but we know that we've got to build more housing, and building contributes has a huge environmental impact. Maybe timber CLT can help there in some way. What about more broadly, like, do you think these processes, these materials can expand like beyond that to other architecture? I mean, you were talking earlier about Gehry and Bilbao and Walt Disney, and those are very sculptural kind of monumental pieces of architecture. Something which is done with a kit of parts, harder to achieve that kind of thing. You're more limited, maybe. Like, what's the possibility for these processes to expand across all of architecture, or is that not the point?
No, I think it can. I mean, I'm going to let the two architects speak to it, so I'm not going to jump into that arena. It's all deferred to Nuri and Kirsten. But I will say, at least Kirsten touched on it. It's this idea that minimizing the number of parts. So I think that can be done by so many, and then when you begin to productize these components, and where art and components, or art and commodity, are seen as equals, then you can start to take these chunks, if you will, and they go beyond just the CLT systems, right? Pretty soon you're then embedding plumbing systems and electrical systems, and so you end up with this modular approach, as Kirsten's already talked about, where you're able to reduce the number of individual parts, and you have chunks, and these chunks are manufactured off-site. And again, as Kirsten said, highlighting the fact that many are being built in cities, and cities are like open heart surgery, right? It's like in the human body. It's very intrusive. And so the least, what would you say, violence that you can induce by manufacturing offsite, and then having, as Kirsten said, a quiet on-site assembly, I think is very scalable. And it's not that it's probably as sustainable. I personally haven't done the analysis, but you start to even see it when people have to maybe use a different material. They're starting to experiment with light gauge steel as well. And very much this, with the same intent, maybe not the same result, but the same intent.
I mean, I'd say that we do need to, well, you can look at, there's lots of examples of really beautiful buildings that are made out of timber. And I mean, Chiguruban is one example that comes to mind. But also that we're at, I think we're at a tipping point where we need, the climate comes first, and we need to be designing in timber because it's renewable, so that we are minimizing the impact on our environment. We're reducing the load of the buildings, we're reducing the amount of concrete that we need in the ground, and we need to get creative with it. And that's the job of architects. And as I said before, that we might have a kit of parts, and that will work really well for housing, for offices, for student housing, whatever, but it doesn't inhibit anyone. I mean, there's beautiful buildings made out of timber.
I was gonna add too that, I loved that in your presentation, Kirsten. I loved the slide you had. I think you titled CLT volumetric, that showed the comparison in the number of parts between the steel module and the CLT module. Because I think that, designing for these buildings to come together and be demountable, and a part of it is simplifying the connections, right? And if you can reduce the number of parts, it helps the process significantly.
And Kirsten, you mentioned that through the work that you've done, it's kind of completely rethinking, in a way, the architectural process, and designing in this way is very different. like, what do you think it will take to get more architects using this? Like, do we need to change the kind of education system? Or are we teaching architects the right thing? How do we kind of ensure that these kind of innovations kind of proliferate and go beyond the kind of select few people, kind of the specialists, I suppose, and become more widely adopted?
I think it's happening already. I mentioned about policy changing, which is sort of a top-down approach. But I was doing some critting at Central St Martin's this week, and sustainability is at the front of all. Well, not all of them, but a lot of students' minds. And there were some really beautiful, actually, timber projects, ideas around how you could coppice trees, or I think it's there already. And then I was also up at Nottingham this week as well, and they were sort of, I was a bit disappointed because they were sort of thinking, oh, how are we going to shoehorn sustainability into our curriculum? And I think it's not about that. It's about this change in the mindset. It's like maybe, I don't think it's too ambitious to say it's like a new Bauhaus that we're approaching at the moment. So
Gary and Nuri, what are your thoughts?
I was going to say, I think you're right, Kirsten. If you look at the early modernists and that kit of parts, the idea of kit of parts, it goes back to them. But it was really just a design philosophy, right? It was just kind of a way to think about the design process. Here we're actually practicing that, right? We're really starting to put that into real practice, and we're doing that because of the convergence of all these elements, the technology, the manufacturing, the understanding from other industries. It's really coming together.
Great. Well, thank you guys so much for your time. Before I let you get back to your busy days, we've got a few questions from the audience who have been watching. First of all, Dixita asks, what are the main challenges when designing with CLT? I guess we've spoken a lot about the benefits. What are the drawbacks? What are the things that need to be overcome?
I think with any relatively new material, there are lessons that need to be learned, which is also part of the piece that we're doing on Horizon with the Building Wood project. So we're looking at it's simple things, really. It's like, don't have a flat roof. Make sure your roof is pitched. So it's trying to minimize any water ingress, essentially, is one of the issues. And then it's a slightly different way of thinking about designing for fire as well. So it's actually more predictable in fire than steel is, but you do need to make sure that you're sizing the CLT to allow for charring, or you're making sure that the plasterboard that you're specifying is appropriate for the scale and size of the building, which we do anyway for any project. But I think they're the two main ones that people talk about, but there are solutions for all of them.
And this one is probably more for Jerry. And Nuri Miles asks, could a virtual twin be created for a building that already exists, using resources and input from those that manage the facility? So I guess this is thinking more about less the kind of design process of that building, but its kind of life thereafter.
Yeah, I'll let Nuri speak to it as well. And absolutely, I mean, I don't think there's anything that prevents it. There's actually a lot of learning that happens when you take an existing structure, an existing building, and you digitize it in a new way. It's for sure an opportunity to capture new knowledge. And so it's not restrictive to just new, but existing as well. Nuri?
I would say exactly, the process of digitizing in even existing building would teach, the people who are operating and owning that project, how it was put together, and how to continue its life in a more sustainable way, be able to control the building, understanding it as a system, as that it can be really managed sustainably. So yes, I think that's definitely a great application.
Great. And just one more question. I might need you guys to help me translate this actually, but Rory asks, can you use non-IR spatial surveillance to monitor heat loss? I suppose this is thinking a little bit more about the idea of digital twins and the sensors that, Jerry, you mentioned a little bit of, maybe that's more for the future. But I guess this is thinking about, I guess, energy through use of the building. Is there a way that this technology can be used to monitor that and I guess find ways to minimize that loss or increase the efficiency, I suppose, the thermal efficiency of the building?
Yeah, I mean, there's so much, this whole notion about sensors and digital technologies, this may sound strange, but it actually goes back to the early years at Dassault Systems with the whole innovation in the 80s, early 80s, first in aerospace and then automotive with anti-lock brakes. And so if you think about anti-lock brakes and how they need to perform in the actual environment, what's the humidity level? Is the runway wet? Did it just snow? Did it just rain? What's the speed of the aircraft? All of these things. And of course, we can apply it directly back to automobiles. But that idea of using the environment and the performance of the product in context of that environment has been something that's been happening in aerospace and automotive for years. At the, I'm forgetting the name right now. At Lawrence Livermore Labs in Berkeley, a gentleman is doing research leveraging this exact technology from us, our Dymola technology, where they're able to get performance data. And it's the same technology that was utilized back at the anti-lock brake days. And so it's completely possible. Now, is it common? No. Is it uncommonality make it unimportant? No, it's definitely an area to investigate, and it's completely possible now. And it's happening. I maybe as someone else talks, I'll look up the name of the gentleman that's doing this research with our Dymola technology. But it's completely applicable, and what the gentleman was referencing really is that early work of performance in context of the environment was really happening kind of during those anti-lock brake days, the early development of it.
Nuri, do you think is that just thinking about the kind of digital twin side of the conversation? Do you think that idea of the kind of the network of sensors, the real world, feeding the digital twin with that real world data, creating, I mean, I guess the metaverse is a word that gets used a lot, but kind of creating a digital version of the real world that's constantly being updated with data from the real world. Is that a realistic possibility in architecture, in design, for the built environment? Do you see a future for the technology to be used in that way, to be thinking about how to improve our cities, whether that's through traffic flow or pedestrian flow, or the impacts that a new building or a new piece of infrastructure might have on the kind of wider urban context?
Yeah, I mean, from a technology standpoint, for sure, it's already becoming possible to install live sensors and have feedback. I think the question is, what do you do with that information, and how much can you change, and adjust once you have that information? I think that's one aspect of digital twin, but it's important to keep in mind also that, like we were saying before about capturing knowledge, taking expertise and really finding ways to embed that expertise in the process of design and designing for manufacture is an important aspect, because it's at that point that you have an opportunity to really change things, right? Before anything is built, before anything has kind of started in the making process, you have this opportunity. So even if you're collecting sensor data, what do you do with that? Do you take some of that information and address it to the next project? do you have the opportunity to, how much can you change what you currently have already built? I think the real opportunity is how can you embed this real world experience and information as early as possible when you can really make big changes.
Yeah, and I would just, Ben, let me add to that, because as Nuri provided me a little bit of time to open up my browser here and do a little searching, the gentleman's name that's doing some of the most groundbreaking research as we're speaking about the importance of language, digitizing through language, is Michael Wetter. So that's Michael and then Wetter at Lawrence Berkeley Labs. And his whole research is using the Medallica language. And he's built a number of, it's the same Medallica language that was used in anti-lock brakes research in the mid-'80s. And so that's Michael Wetter doing that research. He's contacted from throughout the world. It's cutting edge. It's incredible what he's doing. And that Medallica language is used in our 3D experience product called Dymola, Dymola, the same Dymola that was used again in the anti-lock brakes. Now, Michael Wetter has taken that at the building level with a great detail, and at the city level, by the way. So he's doing city level research as well because of the scalability of it. So just for reference and for people who are watching and listening, they could look it up on their own and perhaps gain some brand new information they may not have been aware of.
Great, thanks.
I think that's sorry, just what Nuri was saying about how early you can bring that kind of analysis into the process. I was talking to a modular manufacturer in Denmark, and he was saying that they build one module and then they have the client come round and they work out what all the errors are with it, and before they kind of roll out the rest of the manufacture. If you could do all that analysis without actually building anything, that would be amazing.
That maybe leads on to the last question we've got, which is going back to mass timber. Saurav asks, thinking about affordable housing, and he asks how we can achieve low cost of construction with mass timber, considering material acquisition, processing, policy level decisions required. Maybe you could talk a little bit about that, guys, and how is the process more cheaper, essentially?
Well, I think the big difference is the speed of construction. So you're reducing your prelims through on the project compared to in situ concrete building. So I would say that's been the main, when we're working with clients and talking about timber, that's one of the main reasons. But I think there's going to be a lot more clients coming to us about embodied carbon as well, and that policy change that I mentioned will have a big impact.
And going back to you guys, Nuri and Jerry, I guess that also relates a little bit to the McLean curve that you talked about, and how these, put more effort into something, it's going to cost more. Because it's going to improve something, it needs it's going to cost more. There's going to be more time, more money. You mentioned that these technologies and CLT allows you to kind of flip those curves a bit and say, actually, you can have a better quality at lower costs. Is that true? Again, it sounds almost a little bit too good to be true. How does if you could just speak a little bit about that before we
that's a good point, Ben. I mean, I think that the thing is I've just experienced it in my own lifetime. I mean, when I was growing up in the 70s, my economic means weren't that great, and so I had to get a job in high school and work at Burger King. And off of Burger King salary, I could not afford. It was hard to afford. I definitely could not afford a new car in the 70s, and I could not even fathom a used car. And I could reasonably depart from Dassault Systems and I could probably go to work at Starbucks, and I could buy a pretty nice Honda Civic with incredible scope and incredible quality, and the cost and time has been kept in check. And so we experience that every single day. Nuri and I were having a side conversation a week or so ago, and if you think of mobile phones, right, smartphones, look at the scope and quality that you get from a smartphone. And people, to use the car analogy, young people will pass on cars these days, and they will own a phone before they own a car, right? And because of the functionality that they're getting and the scope that they get from it, but also the quality. We for sure experienced that firsthand. And that innovation is starting to happen in aviation all over again. There's a company called Joby Aviation in the US doing some remarkable things with, full electric Uber type drone services where they pick you up and drop you off. So aviation and everything, all industries are kind of reinventing themselves. But it's happened in the past. It's just happened. It's happened so many times, and we've experienced it constantly as product buyers in so many different segments of product development. And I do think the work that Kirsten is doing, that Waugh Thistleton is doing, and others are doing is phenomenal with DFMA and mass timber, because that is the promise. So it's completely doable just because it's already been done. And again, back to that refabricating architecture book of 20 years ago, that was their argument. That was what they presented. It's being done. That was their research. They visited Boeing, they visited Toyota, and they kind of had that epiphany and saying, look, if it can happen for shipbuilding, shipbuilding's probably, the closest thing we have to architecture. Perhaps it's more complicated because it's moving and floating, and it has to have its own sanitary system, its own water supply system, its own hospitals. Plus, it's got to house 9,000 people, right? That type of thing. That's happening, and those products are being delivered at scale. And so it's just absolutely possible. I just think that it's not to say that people have been performing any kind of malpractice. That's at all for the last 20 years. It's just that, as Kirsten said, as Nuri said, we're just at a really interesting tipping point, and some combination of things have come together that just were not coming together 10 years ago, 5 years ago, maybe 6 years ago, let alone 20 years ago. And so I guess I would leave it with absolutely. The answer is yes, because it's already been done and we all experience it.
Great. Well, that seems like a suitably positive note to end on. Thank you so much, guys, for your time. Super interesting discussion. Thanks for being part of it.
Yeah, thank you. Thank you, Ben. Thank you, Kristen.
Yes,
Thank you.
Thank you all.